Alrighty, well, it looks like some of the assembled or some of the would-be assembled are still at lunch, but that's all right. So my name is Jonathan Hoffberg, and I'm the founder and CEO of Visor. We design see-through head-mounted display applications for industrial environments. And I'm going to talk a little bit today about the implications of our space on the Internet of Things and vice versa. And just, I think actually these two industries are on parallel paths because they share some of the same drivers, and both on the technology side and on the business needs side. So we'll talk about that. So our first foray was to create a lightweight see-through display for consumer applications. And we were way out ahead of the curve. I mean, when we were shopping this around to investors, no one had heard of Google Glass or any of the current crop of see-through displays. And most thought that this was sort of going to be a SkyMall type of application where it was going to continue from where the video glasses left off. But the truth of the matter, actually, is that see-through display is a completely different use case than a video display. And the reason is because see-through displays are all about enhancing situational awareness. So I wanted to share the definition with you of situational awareness that we use, that is sort of the established version of this concept. It was coined by Micah Ensley in 1995, who's now the chief scientist of the US Air Force. And I'm not going to read it, but essentially the issues that are most interesting to us are perception, comprehension, and projection, right? The ability to understand or to see our environments better than we do with the unaided eye, to make use of this avalanche of data that's coming to us from the Internet of Things, the ability to make sense out of that, to apply analysis to that incoming data, and then to use that analysis to deliver inferences or predictions about what's going to happen next. And everything that we're focused on now, which is essentially creating an application layer on top of see-through displays that are coming to market, is really focused on addressing these three fundamental elements. So what does that mean for head-mounted display and the Internet of Things? So head-mounted display is great for displaying information on the go in a highly personalized way, right? Because you can create, as an application designer, an experience that's tailored just to that person. And you can, if you're designing a system, you can funnel very customized experiences, much the way that we do in mobile application design for the head-mounted display. But of course, as we get into augmented reality experiences, that user experience can be extremely customized according to exactly where your head is located, for instance. Of course, these experiences rely on real-time data, and a network of sensors in the environment is crucial to creating experiences that make head-mounted displays useful relative to the constellation of devices that we already have at our disposal, right? So the military translation of these concepts in its current form might be represented in the head-mounted display system for the F-35 Strike Fighter. And this is sort of an example of one extreme of what a see-through head-mounted display could be. And in a way, when you get all the way to that extreme, you're dealing with an entirely different animal. Because what this is essentially video glasses attached to a system of dozens of cameras on the fighter plane that are all pointed in all different directions that are where the frame refresh is so high that the pilot actually feels like he's looking at the world with the unaided eye, except that the post-processing of the video subtracts the plane. So the pilot looks around, and all he sees is the surroundings in 360, and with instrumentation and targeting information overlaid on top of that. So that's sort of one extreme. But for consumer and commercial applications, we are not quite there yet, nor I don't think are we headed there. So let's talk about some problems that are more representative of the kinds of things that we all face every day. So the distracted driving problem in the United States alone is a $40 billion a year problem that is, at least in part, a result of the interface issues associated with the handset, right? The handset is a tiny screen, a couple inches on a side, with an even smaller keyboard, right? And the biomechanical complexity of looking at that tiny screen and the refocus required to do that in a long-haul trucker situation increases their crash risk by up to 23 times. And the biomechanical complexity of manipulating the keyboard finishes the job. So our thought was, well, you know, if it works for fighter pilots, why not for soccer moms? Well, investors didn't really buy that line of reasoning. But nevertheless, the underlying scenario has merit. But we had to follow it a little further before we were able to really find where the rubber meets the road. So, so initially we had this, Visor 1.0 was sort of geared towards consumer applications, driving, recreation, security. But even there, we realized that head-mounted displays, while they're good for biomechanically complicated tasks, for hands-busy, eyes-busy users, they're really, it's really important to match the experience in the device to the mission, right? So a driving display is not a skiing display, is not a security display. And one thing that's challenging in creating a startup is correctly identifying that market before it appears, right? So one good way of doing that is to really focus on the applications if there are actually other devices out there that we can use as sort of trial horses in these various environments. So that's sort of where we're focused now. So the current state of head-mounted display, of course, everybody knows that Google Glass is in the game, and you know, they've made a big splash. Google Glass really is sort of it's a dashboard, right? I mean, for those of us who are AR aficionados, we recognize that it's the first baby step towards a real augmented reality experience. But it's still an important one, right? Because it gets real-time data to the user in a hands-busy, eyes-busy user in an important way, right? And then the Epson Moverio is an example of the beginnings of consumer-grade augmented reality display with a wider field of view such that you can actually paint objects in the environment and so forth. So these are the challenges that we're looking at now, right? Where failures of communication are creating large and quantifiable problems in industrial environments. And there's a whole area of study that's just around crisis management after something terrible happens. How do you get the workers off the rig, or how do you help a firefighter engage in a nightmare situation like this? But the situation that I think is more interesting is the scenario before this happens, where you have the opportunity to fix it. You have this massive amount of sensor data, right, on a rig that is becoming smart and networked. But our ability, right now, it's all going into these central command and control centers within modern drilling rigs and refineries, and that's where all the data happens. But what we really want to do is want to get the data out to the workers that are twisting the knobs and they're out there observing, so that when they see something in the physical environment, they can immediately reconcile it with the data environment and know whether or not this is something that they should be concerned about. And that if they can do that in a passive way, then it increases the likelihood that that the worker team as a whole is going to be able to identify situations before they become crises. So we've been putting together a number of different kinds of visualization scenarios for different environments. This was for a factory where there's automated welding, for instance, where you could see the data for the weld as well as the progress of the robot in the process of welding a pipeline together. And weld quality as a visualized component, not just as a bunch of numbers, so that you can begin to understand what you're looking at, not just from the physical perspective, which is difficult to resolve. You just see a bead, right? If you're looking at a weld, and there's things that you can tell about that, but to be able to parse all the data that comes along with that so that you can see when there's a bad weld before that pipeline is put into service, that can be a huge save for a manufacturing facility. So here's some industries where we've done some exploration. Oil field services, which I alluded to just now. Inventory management and logistics. We were up at Amazon back in February to talk to them, to their supply chain organization, about how head-mounted displays could be used in their warehousing operation, and commercial construction, which is our most recent area of engagement. So now I'm going to sort of flip over to a use case that I want to take a little closer look at. So commercial construction scenario is an area where there's enough need that we found willing partners in terms of engagement for a solution, and yet the problems aren't so dire that it's almost impossible to even get in the room, right? So here's a situation that we explored with a commercial construction vendor. They assemble curtain walls, which are essentially window assemblies for commercial office buildings, stadiums, and other facilities where there's a large amount of glass. And here's what their cost structure looks like. So 20% is materials. Another 8% is fabrication. Engineering, general contractor overhead is another 7%. Installation is 15%. And profit is only 10%. And why is that? It's because rework and waste is 40%. And this is not just their problem. This is an industry-wide problem. And in commercial construction, there's a huge cost associated with the inefficiencies of doing business. And part of that is due to the inaccuracy of inventory management, communication, poorly defined and integrated processes. And in other industries where we have made great strides towards reducing waste and improving accuracy, those are industries where we've been able to take advantage of IT technology and measurement technology because we're sitting at desks, right? But in environments like commercial construction, where many of the actors are actually just out there in the wild and their access to data and communication services is heavily compromised, that's sort of ground zero for head-mounted display, but also for the Internet of Things, because this is where a network of sensors can provide data back to those workers in such a way that they can make better decisions. So these were areas where we thought we could really help this particular customer. Real-time data, and that's primarily around positioning, right? So helping a 6-man team to position a curtain wall assembly which might weigh 2,000 pounds per segment and which might be unique to the tune of like maybe 3,000 similar objects on a job site, right? So knowing which object is up there and exactly where it is relative to its landing place is really important, both for the crane operator and also for the spotters that are placing it. The ability to collaborate and the communication services required in order to provide both point-to-point communication and visual communication. The ability to monitor the status of the job, to train new folks, because labor is a huge challenge for industrial contractors in terms of training new labor and retaining experienced labor. And finally, inventory management, and just making sure that everybody knows where the material is from the time that it arrives at their factory in order to be assembled to the time that arrives at the job site and is in place and installed. So our tenet is basically to avoid problems like this, right? More visor, less this. So these are the kinds of scenarios that we're really focused on, right? So what does collaboration mean? So for us, it means the ability to reference data from a centralized database that's keyed to the job site so that you can pull up the part that you're looking at using a QR code, right? View it, expand it, you create an exploded view on the fly, create a question on a slide that you can then send off to a remote expert for clarification. To be able to do this in a hands-free fashion is sort of the goal of the kinds of solutions that we're focused on. Monitoring, right? So to create a system of sensors on the job site so that a general contractor or supervisor can readily determine whether the job is 100th done or completely done. And sensors that facilitate this could be light sensors, ultrasonic sensors, contact sensors. But the goal is to create a network on the environment so that you can generate these kinds of views to address the cost basis that I described earlier. And finally, communication services are critical, of course, to improving the quality of an installation and reducing the amount of rework. So, right now you've got industrial installation teams on ClearCom, and that's their primary means of communication, right? So it's one channel, no privacy, no point of presence indication, no visual, right? So if we can provide them with a robust system of cameras and presence indication that is part of the way that they're working, then we can radically improve the quality of communication. And it's our assertion that with that, we can, again, address that cost basis that I described earlier. So precise positioning is another frontier for see-through head-mounted display. And this is, again, an area where an Internet of Things kind of solution can have an important bearing on our ability to provide visualization to our customers, right? So, for instance, a system of sensors on a crane can provide us with precise knowledge of where that crane is, where the base of it is, and where the business end is, so that we can locate and we can essentially use a building information model, right, a CAD model of the site itself, in order to steer that crane into position. And then on the other side, the ability to provide that positioning information will assist the spotters in terms of accurate placement of prefab components. And here's the thing. This may seem like a very specific case, and I use it to illustrate a point. All of commercial construction is essentially moving towards the assembly of increasingly complex prefabricated parts, right? So the ability to solve these kinds of problems is, maps across that entire space. And the ability to achieve that is essentially predicated upon the facility with which we can place sensors in the environment and the quality and accuracy of those sensors. So at this point, we're focused on creating a base station, which is in essence a device that is capable of extracting information within its theater of operation so that we can convey that information to head-mounted displays and other visualization solutions for solving problems like the ones that I described. And of course, you need some basic infrastructure. A lot of times on a job site, you are looking at sort of a prehistoric environment where you might not have the basic Wi-Fi infrastructure, the basic internet infrastructure that you need in order to even serve as a foundation to deliver the kinds of advanced solutions that I'm talking about. So just on a very basic level, we're talking about putting systems in place that facilitate the sensor solutions that we were discussing earlier. And so I'm just going to wind up by talking a little bit about the problem that the base station really addresses, which is that while there is a wide range of positioning solutions that are available, indoor positioning is really hot space within our sphere of operations. There is sort of a gap in terms of our ability to really precisely position objects in the environment. And for construction contractors who have, some who have very detailed tolerance requirements. Like for instance, if you're hanging glass, your tolerance requirement is a 1/16 of an inch per 16 feet, which on a commercial job site is very high. Whereas the cement layers are working with a tolerance of like a couple of inches every 16 feet. So the cement is laid down and it's basically grossly out of shape by the glass contractor standard. And they have to go in there and figure out how to fix this, right? And so understanding how, the difference between as designed and as built, and how that translates into exactly where to put all of these objects on a job site. These are the sort of challenges that we're confronting right now. And so that's our current area of inquiry. But I don't know exactly where I am at in terms of time. Oh, I'm actually pretty close. We've got 3 minutes for questions. So I'll start with you.
Under 10 centimeters, you got optical versus the camera versus the SF.
What's that?
When you're doing the measurement placements for the under 10 centimeters.
Would you actually mind saying that into the
Yeah, no problem.
into the mic so that we can get it on video and also everybody else can hear it?
The under 10 centimeters, you had optical / SF. What was the SF?
Was it SF? Let me see.
Yeah, on the bottom there where you're talking about the under 10 millimeter precision.
I think that's a typo.
All right.
But optical and ultrasonic are basically our options at that level, and so that's sort of where we're focused. Other questions?
What generation are the glasses in right now?
Well, we are currently functioning as a solutions company, so we're operating with devices that are coming to market today. I actually have an Epson Moverio up here if you want to take a look and see what that's like. It sort of meets the minimum definition of an augmented reality display. And Google Glass, I would say, is the Google Glass and the Vuzix M100 are, say, the two dashboard style displays that are sort of the front runners in that format.
So you're working with them as well?
Yeah.
So you work with the construction companies, and how open are they to these type of new devices being deployed on site and their solution?
That's a great question. They're kind of schizophrenic about it because on the one hand, they love the concept. But in terms of the way that most of the companies are structured, it's a very risk-averse industry. And it's not a very IT-friendly industry either. So those are the obstacles. But there's a handful of leaders where that recognize the power of this technology, who have enough at stake that they're willing to take a risk here and there on a pilot or a commercial engagement. So that's where we're playing right now. Anybody else? All righty. Well, thanks so much for your time.